Thank you everyone for joining us for this webinar on the history and evolution of automated lighting, presented by Craig Rutherford and Brad Schiller. My name is Mallory Misnarsic and I'm the project manager here at Harman. A few things before we get started. Everyone on the call is muted to keep down noise levels during this webinar. However, there is a Q&A function where you can submit questions to the presenter and they'll try to answer as many as possible at the end. This webinar is also recorded and a link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control. We encourage you to take a look at the different webinars in our Learning Sessions Workshop series on pro.harman.com, as well as visiting Harman Professional Training to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to Craig Rutherford and Brad Schiller, the presenters for today's webinar. Craig is a lighting designer based in Minneapolis, where he lives with his partner and 5 children. Having had an interest in production since childhood, he's worked as a technical director, a touring lighting director, and a full-fledged production and lighting designer. Brad has been involved in automated lighting for over 30 years and is currently a business development manager at Martin Professional. He is the author of the Automated Lighting Programmer's Handbook and a regular columnist on PLSN. A self-described lighting geek, Brad enjoys sharing his knowledge with others. And now I'll pass it over to you guys.
Thank you, Mallory, for that wonderful introduction, and I'd like to thank each of you for joining us today or for viewing this pre-recorded presentation.
Yeah, and thank you again, Mallory. We're really excited to take you on a historical journey through our little industry. We have lots to share, so fire up your time machine as we look back through the years.
There are many, many products, moments, and times and places that have had an impact on the history of automated lighting. And throughout this presentation, we plan to address those that had the most significant industry impact. Given the constraints of time, we had to pick which ones we thought were the most important or the most relevant to the evolution of automated lighting. We're going to really focus on the evolution, those products that really contributed greatly to the industry. In the course of our research, we learned a lot, and a lot of it is really, really interesting. So before you ask a question about, hey, you didn't mention my favorite light, the super bright Mega 5000 from Super Company 5, just understand that we probably looked at it, we probably considered it, but we just didn't mention it here because, you know, we want to be respectful of your time and the time of this webinar. Also, we don't want an info dump to the point that your collective eyes glaze over like so many load-in donuts.
The last 40 years have seen incredible growth and hundreds, if not thousands, of different moving light products from around the globe. So today, we're going to highlight key industry moments and products that define the evolution of our industry. Now, we have to admit up front that we are somewhat biased upon focusing on the major brands and our geographic location, which is North America, the United States. There are, of course, other products in different regions that may have had significant importance, but they didn't take off globally, and so we probably won't talk about them. You're also going to see lists of products here on the screen with release dates. That information is and can be really hard to pin down perfectly. So there might be some minor inconsistencies with other information that you can find online, but we have made a really strong attempt to be accurate. And there are far too many products to fit on these pages. So we have shown as many as we could find, but know that before we begin, there are hundreds more than appear on just these slides.
Right. And before we begin, we want to give a big shout out to our friend Paul Peltier, because he's generously allowed us to use this great library he has of historical lighting equipment photos. As we researched, we found that photos are kind of hard to find of a lot of products, or if they are out there, there were some concerns over copyright and whatnot, but Paul graciously allowed us to use any of the images from his website. Please take some time and check out his website later today or tomorrow or whenever. He has a really great wealth of photos of really exciting and classic lighting products. Also, we reached out to other friends in the industry to receive photos and information. And for all those that we reached out to, we want to say thank you.
Yeah, so put on your seatbelts because we are going to travel through 40 plus years in the next somewhere around 90 minutes. So our journey begins with the very first moving lights to see the light of day. So in 1906, we see the very first moving light patent, which used cords to adjust pan and tilt and zoom and an electromechanical color changer. So it seems as though the inventor intended this device to be used as a sort of remote follow spot, because the patent application mentions, with my invention, an operator concealed on the stage may cause the rays of light to be projected upon and moved to and fro with any figure moving about the stage, end quote. Moving on to 1925, we see the first electric motor controlled repositionable lights, which looks like some kind of mad scientist machine that you can see here on the slide. And around this time, we start to see some incremental steps toward what would become automated lighting in the sense that we all think of it today. We also saw the development of lights that could be repositioned. It's important to remember that these advancements tended to happen with the goals of theatrical productions in mind, right? So early theater drove a lot of automated lighting advancement because theatrical productions were the sort of preeminent, large-scale performative event that most people would have been familiar with and would have attended.
Yeah, and theater shows at this time were not preoccupied with questions of moving lights around during a performance, although when they used follow spots, of course. From the perspective of the individual lighting designer and electrician, what was more important to them was focusing specials and banks of wash lights. That was more important because that's what was time-consuming for their jobs. The need for a system to remotely focus a fixture instead of physically laying hands on it was a prime factor in these early lighting developments. In addition, a remotely focusable light allowed for it to serve more than one function in a scene, repositioning itself between cues. They found it was very useful if they could reposition between cues. This also allowed for fewer lights to be used in a production, saving on everything from electricity to the number of instruments required for a production. Starting around the 1950s, George Eisenhower, who's a pioneer in the field of stage lighting, he began many experiments with moving light fixtures, again for that repositionable type purpose. Several of these concepts led to his work, his future work with Century Lighting, where he created motorized ellipsoidals and Fresnels. Eisenhower also invented some of the earliest dimming systems for stage lighting, and he held over 27 patents for various technologies that are precursors to technology that we still use all the time, including automated fly rails and lots of lighting elements. He also held a patent on lighting control circuits, and that patent is the basis for all modern moving light consoles that we still use today. He's truly an innovator that we all owe a lot of gratitude to.
Yeah, and so starting in the late 60s, we began to see ellipsoidals with mirrors and pars with pan and tilt and some color changing and gobo changing concert fixtures. Now, there seems to have been a lot of do-it-yourself spirit in the early lighting engineering folks. So Peter Wynne Wilson and many others were also developing, mixing up colored oils and waters to use with large format projections during this time as well. And they also had some gobos and iris and color wheels implemented in slide projectors, which saw a lot of use in the early Pink Floyd concerts.
And then towards the end of the decade, around 1969, lighting designer Jules Fisher developed a movable parking system that had pan, tilt, and zoom. And this light actually went on to be used all the way into the early 1990s. Now, coincidentally, he called this the Mac Spot. It had no relation to Martin at the time, but it was called Mac Spot back in 1969. This fixture, his concept was he wanted to represent Tinkerbell in a production of Peter Pan. And it actually marks, this is what's really important here with this original Mac Spot from Jules Fisher, was his idea was to represent the moving light of Tinkerbell. So it's actually one of the first purpose-designed moving lights with the intention of actually seeing the light move as part of the show. Then in the 1970s, we saw further innovation in the early 70s with a lot of different types of custom fixtures, including what was called the Cyclops. And the Cyclops was created by lighting designer Stefan Graf and his production electrician named Jim Fackert, and they both worked at Fantasy Lighting. And on this tour for Grand Funk Railroad, they decided they wanted to have remote-controlled follow spots because they weren't happy with the local follow spot operators they were finding on tour. So they developed this mirror-based moving light that actually used bicycle chains and various motors to move the mirror from a simple joystick controller, as well as using colored glass moving in and out of the beam. Interestingly enough, it was while on tour with Grand Funk Railroad that some guys in Dallas, Texas went to that tour and saw the Cyclops and got inspired. But we'll get back to that in a little bit.
Yeah, so we'll move on now to 1978, sort of the late 70s and 1980s. So as many advancements in the world of lighting for music first came from the world of theater, a lot of early emphasis was placed on the concept of remote focusability. As we said, the idea of moving beams of light through haze as an effect for concerts wasn't really something that most people were thinking about yet. So prior to moving lights, concert lighting was a lot of pars with gels, maybe with some specials thrown in. Think about the pizza oven design from Queen that you can see here, and you've got the idea. These banks of light required tremendous, unbelievable amounts of power, and they generated consummate amounts of waste heat and gel waste. So somewhere during this time, we as an industry made the jump from lights that can move and change color as a way to sort of get more than one use out of a fixture, to banks of lights that move in sync with each other and change color together. Looks really cool. So it's hard to overstate just how big of a shift that was. And that brings us to the first of our products that we think really exemplify the history of automated lighting.
And as you could probably suspect, we cannot, of course, talk about the evolution of automated lighting without discussing Verilight, the rock band genesis, and Shoutout. Shoutout was the place to go for tours back in the 70s. And it was an engineering team from Shoutout that attended that Grand Funk Railroad concert and saw the Cyclops on tour, and subsequently invented the very first moving light prototype. The VL0 was the prototype fixture, although the naming technologies kind of not exactly, it wasn't called the VL0 at the time. It was simply known as the prototype. There's a little echo there that's kind of throwing me off. Hopefully you're not all hearing me. At any rate, it was simply known as the prototype, or just the VL. It didn't have any numbers assigned to it. That came later. These first prototypes that they made, they were never used for anything other than basically testing, showing to the band Genesis, and resolving future patent issues. Furthermore, these initial prototype VLs, they were only initially planned to be color-changing fixtures that could simply reposition. It wasn't until they actually got the first 55 production units placed into a rig that anyone saw the power of coordinated moves with large lighting.
Yeah, and another time, or another revolution was also taking place around this time in nightclubs and discos around the world. And this is, of course, the invention of the scanner, the moving mirror light. So early nightclubs and discotheques were hotbeds of lighting technology advancement. Many early motorized lights were aimed at the disco and nightclub scene to add excitement to the evening. We've all seen the sort of iconic motorized lights of this era, the Death Star-looking motorized balls that have the colored glass dots on them that spin around. You might remember those from your days going with Susan and David down to the roller skating rink and buying a bag of popcorn with the nickels you got for Christmas.
Perhaps the biggest moment of evolution came with the development of the moving mirror scanner. Hey, Craig, can you try just muting while I speak? I want to see if that helps. Thank you. Yeah, I think that does. Okay, so the first professional model of the moving mirror scanner was the Chameleon Telescan, and this was designed in 1979 and eventually made available in 1981. The Telescan was hugely innovative for the time, integrating for the first time ever a moving mirror with positionable repeatability. The first model offered 5 colors, well, if you count white. It had 2 color wheels, each with 2 colors plus open. By 1985, Chameleon had developed the Telescan Mark II, which is credited as having the very first CMY color mixing system in a moving light. And it used this using 3 plastic Lee brand filters. It also had a frost filter and a 6-position gobo wheel. The Telescan fixtures went on to become the go-to for really big arena-style rock shows of the time, with designers such as Mark Brickman calling it the best fixture on the market.
Yeah, and then finally in 1981, the very first production VL units were ready to go, and the company known as Verilight was founded. So the first workable VL1s were used, of course, on the Genesis Abacab tour in Barcelona, Spain. So it became clear then at that show that Showco Verilight had a marketable product that would help change the concert lighting world forever. Now, the VL1 used dichroic filters, which would become the standard for changing a light's color, as they offered orders of magnitude more color stability than gels did, right? So they resist the effects of heat diminishing that color over time. And they came with 3 color wheels of 7 filters each plus open. The original VL1 also came with a grand total of 2 gobos. Why they gave us 21 colors and 2 gobos, can't seem to find any definitive information on, but it seems as though patterns weren't really important.
Yeah, and the design of the fixture, the upper enclosure or the base in which the moving head is mounted, it contained a power supply for the lamp, and the lamp was known as the APS 250. And also in this upper enclosure was a data receiver card. It was a printed circuit board that translated the Q information that came from the console into low voltages and then sent it on to the rest of the fixture. This data receiver card also translated the lamp start and douse commands from the console and fed them to the fixture. And that allowed lamps to be struck and doused remotely by the operator, which was a pretty cool new concept.
Yeah, and another important distinction to make about Verilight products is that you could only lease them until 2000, and that's when they started selling the VL2000 series. They were extremely protective of the technology. I've been told stories about VL techs taking lights to be fixed into a VL employees-only tent on productions to be worked on in seclusion. This is fairly notable when you think about it. The technology now has become so mature that there aren't really many secrets left to hide. We all basically know how moving lights do all of their tricks these days.
Yeah, I remember those tents. Interestingly, about 6 months after the launch of the VL1, a company called Morpheus Lights created and released what was called the Panaspot, and they started gaining traction in the concert touring world as well. In 1986, we saw the development of the Komar Robot. This was the first professional moving mirror for general sale, which also gets credit for the explosion of scanner popularity following its release. Now, kind of uniquely and interesting here in the US, it was sold through a distribution company that was named High-End Systems. And this was before High-End Systems was making their own products. So they were distributing the Komar Robot. And they decided it was good, but it wasn't quite what they wanted. So they actually made improvements to the light and sold a modified version that was brighter and more reliable than the original from Komar. Plus, the Komar distributor in the UK was called WB Lighting. And they hired a gentleman that you may have heard of in our industry named Mike Wood, and at that time to write custom software to allow for individual control of multiple fixtures from a computer system. And the system is credited as being the very first ever moving light controller to use a mouse and icons with visual display.
Yeah, and speaking of controlling moving fixtures, another milestone in the development of modern stage lighting came with the development and release of course, DMX 512 standard in 1986. So much of the era prior to this was this is all pre-DMX. Just about every major manufacturer had their own proprietary control scheme. There weren't any standards regarding control schemes or connectors, or cables. DMX finally became a finalized standard in 1986, and it specified the now default 5 pins and an XLR style connector, as well as a data scheme and the concept of universes of 512 8-bit control channels. Also, in 1986, we see the release of the Suma HTI. This was an early moving head light, and it was the first to use DMX as its control scheme. So think about that. That Suma light, which is almost as old as I am, would probably be compatible with any modern lighting console because of this standard that we, as the industry, have adopted and have started to use industry-wide.
Yeah, and unfortunately, Suma was a really cool light, but unfortunately, they ended up being sued out of existence due to some patent violations in their systems. So that's why we don't know about Suma much these days. In 1987, we saw further development with Claypacky's Golden Scan fixture. And this was the first light to use stepper motors instead of servo motors. Most of the early moving lights at the time were making use of servo motors, which had a sort of built-in smoothness that looked really, really nice in a moving light application. And they also knew where they were because they had built-in positional feedback. But stepper motors, conversely, are simpler and more reliable. They're easier to make, tolerant of high temperatures, and probably most significantly, they're also much less expensive than servo motors. And that's why now you see most moving lights these days are making use of stepper motors instead of servo motors.
And that's right, more moving heads actually started appearing around this time. In 1988, the Martin Starlight, which was Martin's first moving head fixture, appeared, together with the Tasco Starlight Mark II. Many other products were being developed around this time because the demand just kept building. The demand for moving lights was being driven by this desire that shows had to use all this new technology that was being developed. And then in 1989, just a year later, we see Martin's RoboSkin 1004. This was Martin's first scanner with a grand total of 4 colors, red, yellow, green, and blue. 5, I suppose, if you count open, and 3 gobos, and it used a grand total of 5 DMX channels.
Wow, 5 DMX channels. Well, during the 80s, there were 2 big advancements in automated lighting that really had their genesis during the 80s. Yes, I know, pun intended there. The invention of popularization of the scanner and the invention of the moving head. Those were the 2 defining things, really, of the 1980s. There's many great stories from the 80s about lighting professionals and audiences alike going crazy upon seeing lights moving around on stage and seeing the beams during this era, because it was something that just was unprecedented, not seen before. It truly was a spectacular effect that just wasn't possible before the 80s when we had moving heads and scanners. So the 80s were a great time.
Yeah, and the decade of the 90s, moving into that year, this was a period of tremendous growth for our lighting industry. Manufacturers were embracing new technologies. They were refining and improving their previous designs, and simultaneously, there was a new wave of lighting controllers using the now common DMX protocol to control lights and moving away from the sort of proprietary controllers and protocols of yesteryear. And then in 1990, high-end systems introduced their IntelliBeam fixture, which was a more mature version of the then ubiquitous scanner found all over the world. The IntelliBeam represented more than just technological advancement. It was notable in that it was for sale. So rental companies could now buy their own stock of IntelliBeams and other moving lights and rent them out to any productions that wanted them and could afford them.
And high-end sold tons of the IntelliBeams. It became an incredibly successful moving mirror fixture, even to the point that the name IntelliBeam became synonymous with moving lights in some ways at the time, where just like Kleenex is synonymous with a tissue, people would see moving lights and say, look at those IntelliBeams, even if they were a Claypaky or other brand. And the IntelliBeams were famously first featured on the Dire Straits On Any Street tour back in 1991. Now, it didn't have rotating gobos in it, but boy, could you ever do a gobo roll with the IntelliBeam. You just spin that gobo wheel and you'd see all the gobos pass by, and that was a really stunning effect. And interestingly, you can still find IntelliBeams in a few clubs here and there and theaters around the world. And if they're properly maintained, they actually still work well. And it was so successful that high-end systems continued producing the IntelliBeams all the way through till 1999. Another interesting note is, in a brilliant marketing move, high-end systems decided to put a t-shirt inside the box of each IntelliBeam. And I actually still have my original IntelliBeam t-shirt. Check it out. See that? That's what they put in the box of every one and really got the word out and marketed it. Now, why it wasn't a stage black shirt and why it was a white shirt, who knows? But nowadays, of course, most swag you'll find is in stage blacks.
If you have another one of those, Brad, you can send it to me. So in 1992, we began to see the rise of the generic console. Now, before this, there were a lot of proprietary consoles, as we said, and DMX converter boxes used to control lights. So with the advent of this common control language, DMX, of course, that most or all lights could speak, we had the idea that a lighting controller could be generic, right? So you can load data to control any light that used a given DMX personality into its memory, and then you can use it to control that light. Any light. The joy of standards, people.
And one of the first and one of the most popular consoles for big shows was the Whole Hog, the original great grand pig of them all. Now, originally, back when they made the Whole Hogs, it was a really large desk that had an external computer attached to it as well. And they were each individually numbered. Over time, they actually produced 24 of the original Whole Hog consoles. And Vicky, who's the main engineer on it, he gave them each unique names. In fact, the first 4 were named Eeny, Meeny, Miny, and Mo. Imagine that. So the original Whole Hog also had one of possibly the very first ever effects engines in the world. Back then it was called the Synth Stack, and Flying Pig was the first to apply waveforms to parameters.
Yeah, and another interesting find from this era is the Scan Commander. It's one of the first MA lighting moving light consoles. So it had the ability to control 16 automated instruments. No matter how many channels they need, a brochure from the period breathlessly exclaims, having never met a fixture from Ayrton. It also, uniquely for the time, I believe, had an external trackball that could adjust the pan and tilt of a light. So you could use also XY positional stage data, so that once you defined the stage area that you were working with and the placement of your lights, you could move groups of them around in a sort of follow mode, which is similar to stage windows on modern Grand MA consoles.
Yeah, and what's also interesting with the Scan Commander, it was an early console that I actually programmed on, and in fact, it was the first console that I was introduced to the tracking concept. Now, at the time, it wasn't actually called tracking. MA called it a matrix, and they used these odd symbols like X's and slashes and things to identify which parameter types were tracking versus which ones were hard values. So I always remember that good old Scan Commander. It was a fun time. Whoops, I'm going to click the right thing. Sorry about that. Automated lighting, of course, was advancing in other areas besides scanners throughout the 80s and 90s. It also saw the introduction of the Verilite VL5 in 1992, one of the most well-traveled and iconic washlights in the history of Broadway, theater, television, and concerts. In fact, this was one of the very first popular moving yoke washlights, and it had a unique color mixing system that was part of its enduring popularity. Instead of using flags that moved in and out of the beam or having graduated wheels with increasing saturation, VL5 had a totally new concept of using radially mounted vanes on colored glass. And these vanes would be on the front of the fixture and could turn different ways. And their default state would put the edges straight on into the light, so that allowed the white light to pass. And then as you adjusted the color, they would twist, these vanes would twist, so that the individual vanes would then be perpendicular to the beam of light, gradually becoming more and more saturated.
Yeah, and so additionally, that system, which VL called Dikrotune, exploited the fact that dichroic glass sort of shifts the frequencies of light that it passes depending on the angle to the source. Magenta tinted glass, for instance, appears yellow as you angle it toward the light. This unique louver system forms a sort of jet engine appearance on the front face of the fixture. And it's really attractive, and it's attractive enough to be used as a sort of set design element in its own right. And a lot of TV guys were really into how that light looked on camera. There was also a fourth set of vanes on the front that would either do dimming or a frost wash type of effect, depending on the lamp source that particular VL5 used. And the light was popular enough that it's another of the sort of very old lights that still appears out in the wild, so to speak. You still see them on shows to this day.
Yeah, and a company called Light and Sound Design in 1993, they launched what was called the Icon system to compete with Verilite both in terms of making products and also as being a touring provider. Because back in the 90s, most of the manufacturers like Verilite and Light and Sound Design and Morpheus, they not only were a manufacturer of light, they were also providing all the gear for all the tours and the shows. And so Light and Sound Design, or LSD, they created the Icon fixture, which had a really bright output for the time. It had rotating gobos, color mixing, and a very, very impressive zoom range, from a really tight narrow to a very wide zoom range. They also had their own console portion, and that was integrated to the system with new concepts and new ideas of control, and they also were able to control other industry fixtures as well as their own icon fixtures. And they did this through a conversion box that I always loved the name of. It was called the Universal Guest Luminaire Interface, or UGLI for short. So when you connected external non-icon fixtures, you had to go through the UGLI box. Kind of a funny joke there, but that's what they had. At any rate, many engineering choices of the whole icon system, they went out of their way to actually avoid conflicting with Verilight patents, including their color mixing system and their data distribution concepts from the console to the fixtures. And
then in 1994, we see high-end systems, introducing the Cyberlight. Now, high-end had been producing their own dichroic glass, which was unique at the time. There weren't any other lighting manufacturers making their own dichroics at this time. So they began to produce their own glass gobos in the same dichroic chambers. Their patterns were extremely high quality, and later versions of the Cyberlight were the very first fixtures to have these rotating litho pattern dichroic glass gobos. And while they weren't the first fixture to have rotating gobos, it was certainly one of the most popular early fixtures to have high quality glass gobos with fantastic colors in them. The Cyberlight had a lot of output. It had CMY color mixing, and it had new effects all in one package, and it was an instant hit. So much so that high-end later re-released further models, such as the CX, the SV, the Turbo, and eventually the Cyberlight 2.0. So the Cyberlights really marked the beginning of one of the classic and beloved moving mirror fixture designs of the lighting design world.
Yeah, and interestingly, in the same year, a couple of guys from the Canadian Broadcasting Company, or CBC, had a great idea, a really revolutionary idea. They decided to use primitive wireframe graphics to represent what lights are doing on stage, and to use simple indicators such as F for frost or E for effects. And they could display color by changing the color of the lines of the wireframe beams and make it all real time with data coming from a lighting console. And with this idea, we had the birth of the first pre-visualization program, which was aptly titled Wysiwyg, or What You See Is What You Get. Before the widespread use of Ethernet console data, everybody, of course, was using 5-pin DMX cables, so you had to port that data into the Wysiwyg computer system through the use of XLR input boxes or various dongles. And this ushered in the concept of programming a show offline with an editor so that you could go back later and update things when you plugged into the real show. Lots of other visualizers came after this, but CAS Wysiwyg was the first in 1994. In 1995, Martin released what was called the PAL 1200, and this was really important because this was the first automated light to ever have framing shutters built in, motorized framing shutters. Previously, you could only ever adjust framing shutters manually, like on an ellipsoidal or conventional lights. So this introduced the concept of a fixture that could remotely have framing shutters within. It also included many other standard features such as CMY color mixing, rotating gobos, and variable frost. Now, as we go through this presentation, this is going to be the last moving mirror fixture that we're going to discuss in our lineup. Now, it wasn't the last scanner to be made, and plenty have come after it. And in fact, some continue to be made to this day. But the industry, starting around this time, started to gradually make a shift to moving head fixtures. The technology to make reliable moving head fixtures had improved, and signs of a maturing industry began to emerge. While scanners have a significant advantage in their ability to move beams of light at speeds that rival most moving heads, well, the versatility of being able to point the beam of light anywhere you want and not being restricted with that mirror seems to have won over the majority of the world's lighting rigs.
Yeah, and then we come to another moment in 1995, another watershed moment, and this time in control. Flying Pig Systems releases the Whole Hog 2. Now, it kept a lot of the original whole hog philosophy, but it added what we typically think of today as very standard features: an all-in-one design, tracking, framing, multiple timings in a single cue, which is huge, paths, and 2, wow, touchscreens on the front panel. And it made recalling and recording palettes easier than ever before. So for these reasons and more, including an attractive blue case and integrated palm rest, it quickly became a favorite on tours around the world. Now, it continued a paradigm that was completely separate from the old theater consoles of the past. The Whole Hog 2 did not have any direct access faders. Like you push up a fader and that controls one light. Instead, all of these faders were playbacks, and the user accessed control for each fixture by keying in a fixture number on a numeric pad, and that fixture number was set in the patch. So palettes could be accessed by touching them on the screen, and the user could store a really large number of them, and that made programming automated lights easier than it had been in the past. Additionally, you had soft keys, which appeared at the bottom of the screen, and these were context sensitive. For instance, what we mean by that is, say the user selected a group of fixtures. That bar would show options for grouping and selection order, removing programmer data for those fixtures. So in this way, the whole Hog 2 software really tried to be intelligent about how it presented the user interface to the programmer. And it was highly optimized for programming shows with lots and lots of moving lights.
Yes, it was. And I remember early on when it first came out, the earliest software, there was no effects engine in the Whole Hog 2. Instead, there was what is somewhat famous now. It was called the InstaQ button, and it was one of those soft keys. And the InstaQ button, you would press it, and it would provide random values for the parameters of your selected fixtures. A few years would pass before Fine Systems developed what we all know as the effects engine in the Whole Hog 2. And in fact, they also trademarked the name effects engine at that time. Now, throughout this presentation, you've probably noticed that we've made mention of this patent or that intellectual property dispute or somebody suing someone. And it's an interesting note that we want to make throughout at this moment in time, because when Shoutout and Verilight made the first VL1 back in the day, they patented basically every bit of that original system, including the concept of a moving head luminaire, daisy chaining data, and much, much more. Since then, various lawsuits and patent infringements have shaped our industry in a myriad of ways, from data distribution formats to deciding what patterns and shapes of color mixing glass would be developed. Manufacturers have become embroiled in patent disputes, which have resulted in very cool and innovative fixtures being delayed or possibly never even seeing the light of day. There are also many unspoken royalty agreements throughout the years that often result in a competitor earning money on the sale of another company's product. But you don't hear about these things, but they're out there.
Yeah, and we're not going to do deep dives on any of these lawsuits because this is about automated lighting. But behind the scenes, it's fair to say, I think, that patent law in the United States and around the world has made an indelible and at times unfortunate mark on our business. However, if you are interested in learning more about the industry's patents and how they work, have a look at Mike Wood's website. In addition to great articles and reviews, his site has a searchable database of automated lighting industry patents.
And around 1995, High-End Systems was sued by Verilight, which actually resulted in major financial drains and time sucks for both companies. But it did not stop High-End Systems from releasing the Studio Color in 1996. The Studio Color was High-End Systems' first ever moving head luminaire, and it became hugely popular due to its high output, its color mixing system, and the internal effects. In fact, it was the first moving light to have a pattern glass effect to change what was the normally round output of the Fresnel lens into a more oval-shaped par-style output. And you could actually rotate that par shape and move it around. And this actually went on to become a standard effect that high-end would use in other fixtures, and even other manufacturers would duplicate as well.
Yeah, and then we come to the Martin Mac 1200. So this was not only Martin's very first moving head, it was the first of the now famous Mac moving automated color changer, the second C is silent, series of lights. And it also strived to be what we would now think of as a hybrid fixture. So Martin sold it as being able to do both a spot and a wash effect. And that washability was accomplished with a variable frost filter that would move in and out of the beam. So it really further solidified features that we've all come to expect on automated lights, like color mixing and rotating gobos and other effects, all in a moving head package. And bonus, it was huge.
Yes, it was. In 1997, Verilite introduced the VL7. And what was really interesting about the VL7 is it had a new and interesting color mix system, unlike anything seen before or really since then. Instead of using a set of wheels or flags to move about the system, the VL7 had this concept that the engineers called the CVF color system. Instead of traditional wheels or flags, they used two really large, long, oblong glass plates, and each one had different colors on it. One had red, green, and blue sections that were placed side by side, and each of those ranged from fully saturated to fully clear. And another plate had cyan, magenta, and yellow, again, from fully saturated to fully clear. And by moving these two plates over each other and back and forth through the various colors, the theory was that this would allow designers to access a wide range of very saturated colors without that unacceptable light loss, particularly in the reds, greens, and blues part of the spectrum, which with a traditional CMY system tends to actually eat up a lot of light when you try to mix those deep red, greens, and blues. So that was the concept. But unfortunately, the system had this habit as you tried to transpose from one color or crossfade from one color to another, it would go through these unpleasant green parts of the spectrum or other areas when you're doing those color changes. And most people didn't really care for that. Now with some really advanced programming, you could kind of work around it, but ultimately it really limited the wide adoption of VL7 and that color concept.
And then in 1998, MA Lighting introduced the Grand MA series of consoles. So this lighting desk grew to have some of the most advanced features of any lighting console of the time, including an advanced effects generator, highly detailed color-coded cue list that showed tracking and hard value information. It had a basic built-in visualizer and separately a fully 3D visualizer, which was available to attach to the console via the network and motorized faders. Now, the timely rise of the MA1 coincided with that of the Whole Hog 3, which unfortunately many Whole Hog users were sort of driven away from that platform due to some early software issues. So going into the 2000s, the Grand MA console became very, very popular, and it appeared on just about every festival and tour out there. Now, while it did have a 3.5-inch floppy disk drive, what most people started to use around this time for saving their shows was, of course, the USB drive. And just about every tech, every designer, every programmer started walking around with one of these USB drives on their keychain or in their toolbox instead of carrying around a shoebox full of floppy disks.
Plus, as a bonus, the desk had what is now a famous Easter egg. It was a game called Space Invaders. And this was actually included originally for the engineers of the console, that they put it in there to test the encoders. But eventually, lighting designers and lighting directors and programmers found how to access the game, and they wasted many, many hours playing the Space Invaders during sound checks.
Yes, they did. This year also saw the release of ArtNet from Artistic License, which is a DMX over Ethernet protocol. It may not be the easiest protocol to implement from an operator standpoint, but it has significant advantages over physical DMX outputs, which is that you can send multiple universes down one Cat5 line, and you can decode that information a lot closer to your source and thereby massively reduce all of your cable runs. So there are other ways of connecting consoles and nodes together that existed before this, but they mostly used MIDI signals or they were completely proprietary. MIDI show control, MSC, MANet are some good examples. ArtNet is royalty-free. You still have to give Artistic License credit when you use their technology, but you don't have to pay a royalty to them. So this marked a larger shift in the lighting industry towards consoles being more of a control surface with processing handed off to sort of other networked hardware. And this would simplify the distribution of data, and it would prevent the control surface from becoming slow or laggy due to the local hardware needing to perform all of the show math, right? So with the control surface paradigm, the console sort of hands off the show data to networked processing nodes, which frees the surface up for programming or for show operations tasks. And then we're coming to 1999, and back to Brad.
Hey, sorry about that. Let me make sure. Okay, I'm unmuted. We'll get this back going. Don't know what happened. Good old technology. too much history. All right, in 1999, finally for our decade roundup, we come to 1999 when LSD, who we mentioned earlier, they had actually been bought by PRG in 1998, but in 1999 they released the Icon M, or the codename the Medusa. The Icon M was the first real DMX controllable moving head projector, or as we call it today, a digital light. The idea was tantalizing. Instead of a mechanical carriage inside the light, physically moving bits of glass and metal around to do things in your light beam, why not just use a video engine and some sort of media server to deliver the visuals? And with this, you could do amazing things that simple gobos could not do.
Yeah, if you open up modern digital moving head projectors, what you'll probably find is an off-the-shelf projector with some physical controls going in for focus and zoom. The Icon M, conversely, they built a DLP projector into the moving head housing, all custom. And at LDI, it promised, in 1999, limitless possibilities. Now, while the possibilities might have been limitless in terms of visuals, there were a number of engineering issues that really hampered the widespread adoption of the technology. And one of the main ones, sadly, was brightness. So at LDI, pre-production units only put out about 7,000 lumens. That was quite dim in comparison to comparably powered spots and washes at the time. It's about the brightness of a source 4 ellipsoidal. There's also a requirement to use an Icon control desk for control. There were also some really difficult to get around engineering issues with the micro mirror technology. So the cost also was a bit prohibitive. Nevertheless, the idea remained alluring, and it would not be the last time that we saw attempts at this sort of digital light technology.
So as we move into 2000, some of you may remember that New Year's Eve brought fears of the end of the world due to the Y2K bug. Luckily, we all survived that, and that didn't end the world. And in 2000, we saw Martin release the Mac 2000. And this went on to become one of the most successful lines of fixtures ever released. At the time, it sold over 100,000 units. The Mac 2000, or Mac 2K as it became affectionately known, had three main versions: a profile, a performance, and a wash. And the quality of the effects on this light upped once again the standards for high-powered moving lights. It had two wheels of rotating gobos as well as a third fixed wheel, high-quality color mixing, and the output placed this fixture into high demand for many, many years. Now, although it was a big success, a lot of people actually thought it had very, very lackluster gobos, and a lot of the patterns that looked very similar to each other and lacked contrast in the air. But that didn't slow it down. And Martin was aware of that, and eventually they had an idea, and they released a separate gobo package that lighting companies could purchase and install into the unit. And this was designed by the legendary lighting designer Patrick Woodruff. Unfortunately, that gobo package didn't get much traction in the rental market, but it was amazing. It was really a wonderful set of gobos.
I personally think they looked amazing. The Mac 2000's electronics also came in a few versions. So earlier versions had a magnetic ballast. The ballast is the part that keeps the lamp, the arc lamp, from burning itself out. And ballasts of this magnetic sort can be temperamental and hot and a little bit loud. So Martin released the 2 version of the Mac 2000s, which had an updated electronic ballast. And that coincided with a general shift in the industry towards electronic ballasts for lamp control. Programmers and designers might not have noticed as much, but electronic ballasts were less prone to flicker issues. They were lighter, and they were more energy efficient. And it also marked a shift in the world of lamps toward unjacketed short arc lamps away from bigger jacketed lamps.
And, you know, the world of theater had kind of been away from moving lights. And in 2001, it was finally a time that there was a light made specifically for them. The Verilight VL1000 ERS came out. And this was the first automated ellipsoidal reflector spotlight that was really designed as a moving light to be seen moving around, not just be repositionable, although it often is used as that. And Verilight worked really, really hard on the evolution of their color mix system to get as smooth a mix as possible. Previous Verilights had very nice color mixing, but they weren't quite that theatrical quality. So they worked really hard to really improve the color mixing. And the fixture came in both arc and tungsten versions and had automated diffusion and framing shutter options. Interestingly, companies had to order the units with the features and gobos they wanted included. Initially, there was not just a standard model. You had to order it as you wanted it to be built. You can still find VL1000s or subsequent variants of them on current shows today.
Yeah. So then in 2002, we come to the evolution of media servers and digital lighting, starting again. So high-end systems, of course, had continued their research into digital lighting. And again, in the late 90s, they started collaborating with Peter Wynne Wilson. If you remember that name, he was the guy mixing up colored oil and water shows for Pink Floyd, same guy, along with Richard Bleasdale of Sam Show Control Software. Their collaboration eventually resulted in a project named Vertigo in early patent applications. Now, the software portion of that would eventually become a product that you have probably heard of. It is, of course, the Catalyst Media Server. And the hardware portion became a product that you might not have heard of, and that was the Catalyst Orbital Head. Now, the orbital head would attach to the front of a projector, and it would provide 360-degree pan by 250-degree tilt. So for the first time, this moment, video control could be patched into a lighting console and controlled via DMX.
Yeah, and it's hard to overstate the importance of this milestone. Now the programmer would have the ability to control digital images fed to a projector, and they could aim that projected video anywhere around the environment, all from a lighting console. Video finally was established as part of the lighting designer's wheelhouse. Video control from a lighting desk was simply not possible with any commonly available system prior to the Catalyst system. And this really changed what the lighting designer's role was as they had control of video.
And then in 2003, we see Electronic Theater Controls, ETC. You may have heard of them. They launched their first foray into moving light territory with the release of the ETC Source 4 Revolution. So ETC's conventional Source 4 ellipsoidal was rightly iconic by this time, right? You found it in theaters around the world. It was a standard on Broadway. It was a standard setter for its quality of light and its features. But demand for a repositionable Source 4 was very high. And there were a few custom solutions that would help you do that. There was the City Theatrical Auto Yoke, which was basically just a yoke, an empty yoke that you would put a Source 4 into, and then you could reposition it. But ETC thought that they could do better, and they attempted to do so with the Source 4 Revolution, which was a monstrously large automated version of a Source 4. Now, it was an entirely self-contained unit. It shipped with an internal integrated dimmer, and it was not just an automated ERS. It was not just an automated Source 4. It had an entire plethora of features. It had zoom, it had a 24-frame capacity integrated gel scroller, it had accessory slots and gobo carriages, remote focus, and a bunch of other features. It was unfortunately a little bit slow, a little on the slower side. It did not really see widespread adoption, but it remains a really interesting example of attempts to automate conventional lighting.
And 2003 is also the year that we see the release of what went on to become another classic light from Verilite, the VL3000 series. Now, they made both spot and wash versions of this fixture, but the spot by far became the most popular light and one of the most specified lights on tours and shows around the world. The VL3000 really advanced the state of color mixing with what was probably the best color mix and dimming system of the time. VL3000 had finely etched color and dimmer wheels that gradually transitioned from clear glass to fully saturated. And the dimmer wheel used a graduated mirrored finish that went from fully clear to fully opaque at the other end. At the same time, other manufacturers were using flags for dimming, and this dimming was phenomenal with the wheel. The color mixing and dimming system across the beam was so incredibly smooth. The fixture also had 3 rotating gobo wheels, which was a lot at the time, and continued VL's tradition of having really excellent optical systems. The 3K was around for a long, long time and still shows up on shows now and then.
Now, during this time, high-end systems had not been sitting idly about on this whole digital light idea. They had been actively developing it, and their efforts really culminated with the release of the DL1. This was a digital light that came out a year after Catalyst, followed by the DL2 a little later on in 2004. So these were moving head projectors, which started out with an on-the-ground separate media server, but ended up with the DL2 with an integrated media server. So now designers could preload the media clips that they wanted to use onto the light, and they could control the light just as they could with any media server.
2005 saw the release of two new Martin products, the Mac 700 and the Mac TW1. Now, this was a time that they scaled down the same technology that had been used in the Mac 2000 line, and they created the Mac 700. And in a similar way, it had a profile, wash, and performance versions. But this time it was based on 700-watt lamps. And these fixtures continued the Martin's trend of high-quality optics, and Martin was able to squeeze quite a lot of features into a very compact package.
And the TW1, somewhat unusually for the time, was a high-powered tungsten automated light with an ellipsoidal optical system. It was aimed at a theatrical role. So it output a lot of light because it had a 1200-watt incandescent lamp, a really large lamp. And the position of the effects in the color mixing and dimming in the optical train was such that they were all very out of focus. They were very smooth across the beam. So they saw some use in theaters, but they also saw some work in the touring market because designers really liked that warm 3200 Kelvin inviting source, and they used that to contrast against the more common, cooler color temperature arc sources that were popular at the time.
In 2006, ETC launched a major change, well, for them at least, when they launched the EOS Console. And this platform was their first real foray into having touchscreens and a completely networked solution with their console systems. It had new syntax and a comprehensive feature set. And what ETC did at the time is they redirected their console business to ensure that they would have a solid place in the automated lighting control market. Previous to this, they had several other console lines, such as the Expression and Obsession, that worked with moving lights, but they were oddly different because they kind of followed along with the, quote, conventional mindset of programming conventional lights. The EOS line was developed from the ground up with to be a total control system on par with other leading automated lighting consoles. And it continues to be a very popular line for ETC to this day.
Yeah, I remember when they released that. In 2007, Verilight introduced the VL3500 wash, and this was one of the first 1500 watt washes, and it set new standards in terms of brightness. Now, it competed directly or indirectly with some other higher wattage lights that were made by high-end systems, but ultimately it really became more popular than either of those models. It offered incredible, stunning brightness at a more reasonable wattage, especially when equipped with its plano-convex lens. And it had an internal set of lenses that could hinge open for even greater light output. Verilight called that the Very Bright system, sort of a fun, punny name. And that was actually a trick that the Mac 2000 wash had pioneered years earlier, flipping that lens up to get even more output. The VL3500 threw around also an absolutely enormous amount of glass, which required really powerful motors, but oddly lacked a tilt lock.
This was also the year that GLP released what would become an entirely new class of moving lights, the LED wash, when they launched the Impression 90 fixture. Up to this point, LEDs were starting to take hold on the lower-end disco market or the less expensive fixtures, but this was one of the true first professional lights that was a LED wash light. And the Impression 90 consisted of a flat-shaped moving head and yoke, and it almost had nothing else but a small base for the power and mounting. The head was really, really fast, but the new thing here really was the light source. It consisted of RGB LEDs. And again, before this, companies were starting to get into the LED world, but we weren't really there yet. And because LEDs were new, no one had developed zoom lenses for their fixtures yet when using LEDs. So the Impression 90 had a fixed beam angle. It was also before we had homogenized LED packages. So there were separate red, green, and blue pixels all sharing the space on the head. And some people ended up calling those calling it Skittles or pizza oven lights or something like that. At any rate, it took a few years for the industry to get away from having the multiple LEDs on the head. Still, The Impression 90 really was a watershed moment as it saw a lot of work on shows and paved the way for LED wash lights that came after it.
Yeah, and our next step in our journey exploring the evolution of digital lighting specifically is the high-end show picks, which was a really fascinating venture into sort of a hybrid space between an automated LED wash light and a pixel display. So these were quite large units with a built-in media server that could be used just like any digital projector light. But instead of utilizing a powerful light source with projection to blast the image onto some scenery or through haze, the show picks, and there was a smaller version called the studio picks, they were intended as direct view devices, something for the audience to look directly at the face of. And the show picks really anticipated the glut of LED video products that were about to appear. Somewhat ahead of its time, it failed to find a niche, but it displayed some really cool features. Different lights could be part of a larger video canvas, which is a feature that we see on a lot of pixel mappable pieces of hardware today. There was an explosion in pixel mapping just around the corner, both in terms of products intended to be pixel mapped and in terms of highly demanded features within consoles to do a pixel map across fixtures that weren't necessarily intended for that purpose. Grandame 1, for instance, had a sort of basic built-in pixel mapper that they called bitmap effects. And high-end would actually add that feature to the whole hog series of consoles a little bit later.
Also in 2008, Martin released the Mac III, and this was the culmination of a large and innovative engineering project. It had a 1,500 watt lamp, and Martin designed a brand new color system for this light and directly for the light source itself. And that was, they wanted to emphasize the red parts of the spectrum. The color system they would go on to use on future products, including the Mac Viper series. This was really important because it emphasized making those really bright reds that have always been a problem with the ARP source products. There was also a totally new gobo package with lots of new gobos optimized for aerial and projection effects. And it also introduced some new patented features that a lot of spots would go on to duplicate, one of them being follow spot mode. Previous to this, a lot of companies or shows would open up a moving light and disconnect the pan and tilt and utilize that light as a kind of follow spot. So with the Martin Mac III, Martin built in a follow spot mode that would go in through the menu and disable the pan and tilt for you. And this would allow you to use the light as an automated follow spot, where an operator could just handle the fixture and move it while the console would still control zoom, focus, and beam parameters. Martin even had dedicated handles that attached to the rear of the fixture just for that purpose. Additionally, around this time, companies, including Martin, were looking at these lights were big and heavy and thinking about people who had to actually lift these and rig them. And so Martin had the concept and patented this idea of putting handles on tops of the yoke. And that allowed for easy lifting and easy maneuverability of the fixture. Another feature in the Mac III that became a new concept that's been seen since is having a battery-powered menu system that allows anyone to go up and set fixture modes and addresses without the light having to be powered on.
Yeah, I remember that battery-powered menu. It was the greatest thing. In 2009, we have Production Resource Group, a longtime production and rental development company. They began to make their own light, and they called this the PRG Bad Boy. This was first used on U2's 360 tour. That's the one with the claw, designed by longtime designer Willie Williams. So PRG was explicitly trying to make the brightest spot that they possibly could, and one of the sacrifices that they made in furtherance of that goal was to forego color mixing in favor of what they called the quantum color system. And this was a series of fixed colors so that the light would have minimal glass between the lamp and the output. So they performed really well on the 360 tour, but demand for a version that could color mix was really high. So the company began to work on a new version, which they called the Best Boy, and that would come just a few years later and also include full color mixing.
So as we move out of the early 2000s, we're now going to move into the teens, the 2010s, and no mention of 2010 could be possible without mentioning the Sharpie Luminaire from Claypaky. As you probably know, this is a really famous fixture, so we're going to talk a lot about it. But the evolution of this fixture really stems from an earlier fixture, the Claypaky Alpha Beam 300, which was released back in 2007. This was one of the probably very first really narrow beam fixtures to hit the market. The Alpha Beam 300 took the old concept of an ACL beam, which is a really tight, narrow beam, and made it a moving light. And then they added color mixing and a very narrow optical train to channel all the energy of its 300-watt lamp down to the center of the beam. Unlike the Sharpie, the Alpha Beam 300 used a somewhat traditional jacketed short arc lamp, excuse me, which had to be carefully focused in its reflector to get all the brightness out of the unit.
Yeah, and there were a lot of copycat fixtures immediately released after the Alpha Beam, with just about every major manufacturer coming out with their own version. It really made 2008 sort of the year of the beam, as my friend put it. So following up their success, Claypaky continued to evolve their design for the Alpha Beam 300. They tightened up their optical systems, and crucially, they made a jump in lamp technology from a traditional arc lamp to ones that looked a lot like the lamps that we use in video projectors. Very short arc, pre-focused in a reflector housing. And that completely eliminated the issue of rental houses not focusing their lamps, or the lamps getting out of alignment over time. So all of this culminated in the release of the Sharpie in 2010, and it became one of the best-selling lights in automated lighting history.
Yeah, and the brightness that the engineers at Claypaky were able to achieve with just a 189-watt lamp was really astonishing. The beam that you would get out of the Sharpie would shoot across arenas, even if you didn't have haze. And with the hot mirror that they had in there to block out the UV, the beam still could easily melt plastic items that got too close. We saw large arrays of them become a favorite on many, many concerts and outdoor shows where it was hard to keep the haze around, and of course on many indoor shows as well. Now, the optical characteristics did not allow in the Sharpie really nice color mixing as you saw in the Alpha Beam 300, because the beam profile was really strange and peaky due to that little lamp, and it had inelegant dimming too. But this was a light for filling the air with dramatic shafts of light, and wow, did it ever do that really well.
Yeah, and the Sharpie, and to a lesser extent the Alpha Beam, it represented the beginning of a really big change in how we lit shows going forward, because now, starting with them, it was technologically and economically feasible to have lots of really tight, narrow beams that filled arenas and skies, and suddenly you saw these lights everywhere. They were on every show, from the Super Bowl all the way down to little tiny touring shows. They changed the way that we light productions probably forever.
Yep, beams for days. So around the same time, engineers at Martin were working on creating a profile LED-based light, because LEDs were evolving and we were seeing, again, some early models and tries, but Martin finally released the Martin Mac 350 on tour, and this was the first professional-grade profile LED-based fixture. And it used a white LED source behind in the optics. Interestingly, the head was designed to not fully encompass the go-bone color wheels, and this led to a bulge on one side of the fixture. It was a design choice unique to the 350 on tour in Martin's lineup, and this fixture went out on quite a few tours in 2010 and 2011, 2012, including the first tour, which was Crowded House's World Tour, which was designed by Paul Normandale in 2010. Oop, gotta click over there. Looking ahead, when we get to 2013, we see the release of the Aeroton Magic Panel 602. Now, Aeroton was a small little company that did a few things before this, but this is really what brought them a lot of attention. And it was a real turning point in the history of intelligent lighting as well, because of the eye candy factor. Now, it wasn't really a wash light, although you could use it as one. And it wasn't really a pixel mapping light strictly on its own either, although you could use it as one as well. Its strength was in its versatility. It served as both almost a hard-edged narrow beam with the soft edge of a wash, but with each individual pixel element having a narrow enough lens on it that you can get very attractive spikes of light out of it. The release of the Magic Panel started a fascinating trend within the industry of making lights explicitly with the intention of being eye candy. So the lights weren't being developed just to be a spot or a wash. Now they were being developed specifically for eye candy and moving LEDs and changing things with that. Almost a callback to the early disco lighting days of spinning balls and moving linear battens of light. But now they were professional grade and tour ready products.
Yeah. As the decade then progressed, what we saw was the release of further professional grade LED-based profile lights, with Martin releasing their really successful MAC Quantum Profile hard edge light. Now, somewhat surprisingly, the Quantum, as well as most other LED-based hard-edged fixtures during this time, used white LEDs with subtractive color mixing. There were few exceptions to this, but for the most part, it was white LEDs and subtractive mixing. There were two main reasons for this, I think. One is that the vast majority of lighting applications around the world require high-quality white light. So most of the world's development was and is focused on creating more efficient and more natural-looking white light. And the second is that it's a hard physical problem to solve. It's a hard engineering challenge that's involved with creating a viably bright RGBW, at a minimum, mind you, a lighting system that has a narrow enough optical characteristic to be used as a spot fixture.
Yeah, and another interesting and patented feature of the quantum profile that we've seen on other fixtures since then is a feature that Martin calls animotion. And this is a term for controlling various segments of the white LED source that makes up the light. And what this idea was in the past, we've always had lamps in a fixture, and a lamp is either on or off, or possibly dimming. But now we had an array made up of many different light sources, individual LEDs. So animotion allows a chasing of those LEDs, which allows the beam to shift or gobos appear to move slightly. And it's an effect that would only ever work with an LED array as the main light source. So it was a really cool, exciting new feature as well that we've seen adapted in many ways on fixtures since then. A major advancement also occurred in the world of follow spots in 2016 when PRG introduced their innovative ground control system. And this essentially separated the operator from the fixture. In this new system, follow spot operators would use a floor-mounted device with an LCD monitor on it to control a bright automated light with a high-definition video camera pointing the same direction as the lens. So you had a video camera on the light, and you've got this really cool thing that's set up like a follow spot, but with a monitor on it. And the follow spot operator can pan and tilt their device, which causes the light to follow exactly the same motions as what they're moving this device or their remote. On the video screen, they see exactly the fixture's point of view. They see what the fixture is looking at. So it gives them the same familiar sense of working a follow spot as if they're standing there looking down the beam of light, but from a remote standpoint. Now, this was not the first system ever to allow remote following of automated lighting. In fact, back in 1999, Martin released what was called the TrackPod. But ground control will be remembered as the beginning of a very important industry change.
Yeah, and those were originally just for rent or lease through PRG. You can buy them these days. But this product kicked off the development of several competitors, all of which work in slightly different ways, but they all sort of have the same general idea. The era of truss-mounted follow spot chairs seems to have come to an end for the most part, and thank goodness. In 2019, Clay Packy released the, I'll say it, confusingly pronounced Steelos fixture, which is the world's first professional spot fixture that uses red, green, and blue lasers as the source. So interestingly, the fixture is not a phosphor excited or pumped by a blue laser source like we see with LEDs. White LEDs are a blue LED with a phosphor on top to make white light. That's not how this works. This is a true additive color mixing product. So it mixes its laser light just like any other LED-based product, but with a very different and very proprietary optics. So it requires currently a laser variance to operate in the United States. Has not been seen on lots and lots of shows yet, but it certainly represents an interesting continuation of the evolution of lighting source design. Will we see more fixtures using this technology? Time will tell.
Yeah, and as we leave the teens, the 2019s, and into where we are today in 2020, this decade's already started off with several new product announcements. Martin launched the Mac Aura PXL, which aims to continue the popularity of the classic Aura, but with full pixel mapping abilities, and not only of the main output, but also of the Aura effect, controlling all the pixels within the Aura effect. This fixture also goes on to merge lighting and video with the ability to easily combine control of the pixels through both DMX and Martin's P3 protocol. Now, where are we going to go through this decade? Well, we expect many more innovations and improvements from lots of different companies within our industry, and maybe even some new companies, because we're all dedicated to continuing to evolve and providing exciting and creative tools to designers worldwide. Stay tuned to see what happens.
And as we come to the end, we just want to say that history is fun. And we suggest these resources to learn more about our industry's past. First, check out Lighting and Sound International's digital archive of their magazine, which goes back through the early 80s. You can scroll through the pages and look at advertisements for products that might not even exist anymore. You can read about LDs and how they developed their shows around these products. It's a great way to be not only nostalgic, but to learn some of the history of our industry and process. Also, Richard Cadena wrote a really, really excellent book all about automated lighting, and one of the first chapters covers the early history of automated lighting. So he includes details and anecdotes from regarding many of the great moments of our industry's growth, and you can find that book on Amazon and other retailers.
Presentation, we've talked about many key products and moments, and we actually listed over 250 unique products. As we mentioned at the beginning, there are hundreds, maybe even thousands more that we did not detail due to time, but we do give props to every fixture and every console and every development throughout our industry. We love the diversity of automated lighting products and appreciate each and every one. The popularity of automated lighting has resulted in many strong companies that have thrived for decades. Just look at the dates that these companies were created. It's amazing how long they've lasted and continued to develop new products. We expect our industry to continue to prosper for many, many more years to come as moving and color-changing lights continue to dazzle audiences. We're happy to report back to you in another 40 years with an updated presentation to share that's all that's happened from now till then. With that, Mallory, we'll kick it back to you and kick it back to everyone. Thank you, and we'll take questions.
Perfect. Thank you, Craig and Brad. We did have some questions come in before the session. So the first one is, of all the innovations you mentioned today, which do you think had the absolute greatest impact on the automated lighting industry?
Yeah, I think, Craig, I think I'll jump on that one. I think probably the biggest impact as of now, probably I would have to say of all of them, DMX. DMX is the heart of how we control moving lights. And it doesn't matter these other protocols that have been developed, SACN, ArtNet, they all still are based around DMX and the way a DMX protocol is laid out for products. Eventually, maybe we'll have something different, but right now I think DMX probably really solidified the control paradigms and how we work with moving lights.
Perfect, great. The next question is there a particular innovation that you hope we see in the next few decades?
Particular innovation that I hope we see in the next few decades. I've actually talked with a couple of people who worked on the development of these lights, and they say that the drive isn't really there. They don't think the market's really there. But I really like the idea of a digital light. I think that you can get some really cool looks out of either a moving head projector or a projector with a mirror. I'm not sure why that look didn't really become as popular as all the other lights that we use on concerts these days. So I would love to see a high-powered moving digital projector light, or even something again like the Catalyst or Orbital moving head. I think that there's really great opportunity to do some really cool looks with a video source in a concert. What about you, Brad?
I agree. Digital lighting is the holy grail, I think.
Great. So we have a couple more questions. So the next one is, thanks for the history lesson. Are there any museums that house many of the older products that you had mentioned today?
Yeah, actually there are. Around the world, there's a few colleges that have ranges of products. But one of the most well-known ones is Claypacchi in Italy. They have a really wonderful history of automated lighting, and they have lots of different products, not just Claypaky products. They have representations from everyone, and it's a beautiful place. If you're ever there at their factory, you can go through there. Also, the company called Golden Sea in China has a wonderful history museum of automated lighting that parts of it came from a company in Israel that they moved over to China. So there are several. There's also many online websites that host different photos of them. But what's really fun is to actually go to these museums and see the products. And occasionally at some of the various trade shows, you'll see a manufacturer set up their entire history and have models of their products as well throughout the years.
I've been to that history museum in Bergamo in Italy for Claypaky, and it's really, really wonderful if you ever get the chance to visit.
Great, so it looks like we have one more question. So why do you think that DMX has not yet been replaced by anything newer?
I think it's just very, very easy to use. It's fairly indestructible, right? It works right up until it doesn't. As protocols go, it's robust because I think in part of its simplicity, and just the fact that most moving lights, I think from an electromechanical sense, it works for what they're doing. There's no need to add additional layers of complexity. Some of that is changing, I think, with a lot of the Ayrton lights take a couple of universes if you're using them in like full-on mode. So that might represent a force that would sort of force adoption of something a little bit better than DMX 512. But I think for the vast majority of what a moving light does, DMX just works most of the time, and its robustness and I would say resistance to failure is probably what makes it as popular and enduring as it does. What do you think, Brad?
Yeah, I agree. I think it's very robust, and that's why we've seen it continue through these years. There was the plan years ago with the original ACN spec to have a new protocol, but that really never took off. And SACN was just an initial subset that really uses DMX in a sense. Do I think we should have a replacement? Yes, at some point, I think there should be a replacement. Maybe at our next step, when we do this in 40 years, we can talk about that. Because one of the problems with DMX, of course, is the resolution. When you limit things to a certain number of steps, it really does cause a lot of deficiencies in what could be possible in terms of resolution and color mixing and steps and all that. But as of right now, I agree with all you said, that it's very robust, and that's why we continue with it.
Perfect. That looks like all the questions we have. I want to thank everyone for joining us today. And thank you, Craig and Brad, for your time. This was a great session.
Thank you. And there's our email addresses are on the screen. So if you have further questions, feel free to reach out to myself or to Craig.
Perfect. I hope everyone has a great rest of their day.